yesterday's work. Yesterday's work, we had that little chart, and basically all I needed you to get from that chart is, remember, if A is positive, if A is negative, if N is odd, and if N is even. This is what this chart was trying to tell you. As you're going to the left, as we're going to the left, if my A is positive and my N is odd, that chart told you that as you go to the left, you know that this graph is going to be going which way? Which way is it facing? From yesterday. If I'm going to the left, which is going to negative infinity, I know that my graph is going down. With me. If I am going to the right, which is towards which way? Positive infinity, this thing is going to be going up. Remember, the whole point of this chart is to tell me my end behavior. So I know that if I was have a positive A and an odd N, I know my graph will start coming from the bottom, it will do some stuff in the middle, and it will eventually end going up. So, if I have an A that is negative and an N that is odd, I know that when I'm going towards the left on my graph is going to eventually, at the end, be going up. And I know as I go to positive infinity, it's going to be going down. So here's what that means for me. I know the picture of this graph before I even start. I know that on my left side of my end behavior, it's going to be coming from here. It's going to go like this, do something, and then it's end going down. This is the end behavior I'm referring to. You see how on the left side, the end behavior is going to positive infinity. The right side, the end behavior is going to negative infinity. That's what I'm referring to when I'm talking about end behavior. You already know the ends, what they're going to look like, no matter what kind of equation I give you based on this stuff, this chart. You already know what the two ends are going to look like. If it's positive and even, as I travel to the left, it's going to be up. If I'm going right, it's going to still end up. Because what did we talk about yesterday? Evens end the same way that they started. So it's going to look like this on the left side, maybe do something just a little like that, and then go back up. The end behavior is up and up. That's what this chart is showing us. Are you following me? Do I know what happens in the middle? No. Have I talked about that yet? Not talking about the middle yet. Just talking about the end behaviors. And then on this one, as I travel from the left, it's going to face down. And as I go right, it's also going to face down. So I know this graph would look something like this. It could look just like this. It could just be a parabola. Here's an example question of what they can ask you. If I say f of x equals negative 6x to the 6th. What is a? Do I care about it being 6? What do I care about? A is negative. My n is what? So which part of my chart am I going to be on? The bottom right. And notice the end behavior is what? Down, down. So I know it's going to start down. It's going to do something in the middle, but end down. We haven't talked about these little humps yet or anything like that. I'm just showing you extreme examples. But all I'm showing you is from this, I know it's going to have down, down. Does that chart make a little more sense now? Questions on it? All right, so it says, recall that the axis of symmetry divides a graph into two parts. that are mirror images of each other. Look. So remember, when we have the parabolas, we had this axis symmetry that was a line. And what happened was, if this is 3 points over this way, then this was 3 this way. Correct? It was mirror image. And then you could go all the way around, all on this line, all the way like this. That's how we came up with this parabola, because it was mirror images from this line. Yes? Alright. So they said, sketch 2 graphs that are symmetrical to the axis symmetry. This is x-axis. So, does everybody see the x-axis is right here? If I had 2 lines that were, or 2 graphs that were symmetrical about that. So everybody see I could have a graph that way, but then my parabola would have to go like this, because you see how that is 1, 2, 3 points away? You see how down here it's 1, 2, 3 points away. You see how it's symmetrical about that line. And they asked me to draw 2. So you could draw another one on there if you wanted to. What are they really asking here? When does x equal 0? What's another word they could have put here instead of that? They could have said the y-axis. I'm not going to go through that one, just want to point that out. Those are synonymous. Alright, what if it says x equals 3? Well, that would be x equals 3. That would be right here. If I drew a parabola from right there, that could be my vertex, right? Where do I know my vertex has to fall? On the axis symmetry, right? And then I would go like that, and boom, I've sketched. Remember, this is just sketching. It doesn't have to be perfect. We're just understanding the idea of, if I mirror it, I have to mirror it over there, and it's going to be the same. Are we getting this idea of being symmetrical about a line? And again, what if I said something like this? What if it said y equals 2? The line y equals 2 is like this. Everywhere I'm on that dotted line, y equals 2. So my parabola would actually be facing like this. Now, a question down here is, it says, is each of your sketches a function? Should they say, are each of your sketches? I have to ask my wife. Just because it doesn't sound right doesn't mean, she just yelled at me the other day. Just because it doesn't sound right, you need to know the rules. I'm like, sound like me and Matt. Alright, so, are these up here, these graphs, are they all functions? How do I know? Well, I check this one. Does it pass my vertical line test? Does this one right here pass my vertical line test? Yes. Does this one right here pass my vertical line test? No, it hits twice. So no, not all these are function. That's a quick way to explain why they do not pass the vertical line test. Alright, so that talks about the symmetrical about a line. The line divides the graphs into 2 identical parts. Special attention is given to a line of symmetry when it is the y-axis, because it tells you that the function is even. So in order for a function to be even, the line of symmetry has to be the y-axis. We're going to talk about even and odd later on. Alright, symmetrical about a point. Symmetrical about a point. If each point on the graph has a point the same distance from the central point, but in opposite direction. So here's what happens. You see this? This is my central point right here. If I go over and up, does everybody see that distance would be like this? Correct? Or how could I find the distance between this point and this point? What would I have to use? Distance formula. Are you with me? But if I went the same distance this way and the same distance down, wouldn't these two distances be the same? Are you following me? Do you see how it said in opposite direction? Direction meaning this is going this way. Opposite would be going like that. 180-degree turn would be opposite, yes? So do you see how this has now, this symmetric is about a point and not about a line? Do you understand what I just did there? Yes? Okay, so that's what's going to happen when something is symmetrical about a point. And an even function, we're going to talk about this a little bit, a better way to do this, but an even function is when you can take a negative x and put it in, and it still gives you the same thing out that you started with. An odd function, you can put a negative f of negative x, and it kicks back the original function. I'll show you what that means in just a second. So here's what happens. Remember, it talks about the axis having to be the for it to be even or odd. Do you see how this right here is the axis, and it's a line? Which one was a line? Where are my even functions? You see how the origin is not my point, my central location? So this is neither. And this one right here would be odd. All right, here's where I wanted to get to. I'm going to do A for you. I'm then going to let you do B and C on your own. I'm going to come around and check B and C, and then I'm going to come around and check your homework and stuff that I need to check, and then I'm going to assign homework out of the skills practice. Homework meaning the review that you have in the syllabus that you're supposed to sign, that you guys have all been wanting to turn in. So I'm going to go over A. You are going to work on B and C after, and I'm going to walk around and collect some work. You're going to try to figure out B and C while I'm walking around. We'll then come back together, do B and C together, and then I'll assign some skills practice. I'll put the skills practice up on Portal. If you have to, you can take a picture of the book if you want to. Remember, it's going to be 4 pages, so you have to flip and take pictures of all 4 of them. Or you can just go on Portal and download the PDF file. Does that make sense?
You mean the review? Do you mean like?
So A is a great one to explain. A is a great one to explain because in order for a function to be even, you have to take f of negative x, and it has to be equivalent to f at negative x. That means when I replace, I am taking the x out. I'm going to put a negative x in its place, and when I simplify everything, it looks like I haven't done anything to it. It looks like the original equation. So here's what I mean. If I take this right here, and I go, you know what, I want to see what f of negative x is. That means 2 times a what? Negative x cubed minus 3 times the negative x. If it turns back to exactly what it looked like in the beginning, then I know that it's an even function. So I look. What happens when you have something to a negative something to the third power? It remains negative. How did he know that? Because you got an odd number of negatives. When you have an odd number of negatives, like you were trying to describe, you've got one that's left out, right? In order for a negative to become a positive, you have to have a pair with it, right? Well, in odd numbers, I can make pairs, except I have one that's left out. And that one that's left out will make all the numbers turn back to what? Negative. Are you following me? Because no matter, even if it's a 74, what number is that? If this is a 74, it's a even, so it would kick back a positive number. Because I know my power is even. There's going to be 74 negatives, and each one of them will have a pair to cancel each other out and make it positive back. But since this is odd, I've got one that's left out. So like even if you use the number 11, it's odd, right? So I've got 5 pairs, right? Negative and negative, and negative and negative, negative and negative, negative and negative, and negative and negative. But I've got one negative all by itself. So he's like, screw you guys. We're going to put it back negative. You leave me out. Does that kind of make sense? Okay, so this right here is going to actually make this a negative with 2x to the third. And what happens with this guy? What's a negative x times a negative 3 going to become? Now, I look at this right here. Is this the same thing as what I started with? Then it is not even. Does that make sense? Now, the way to check if it is odd, the quick way to check if it is odd, is to go, you know what? What if the opposite of f of x, what if this equaled that? You know what? I'm going to teach you the right way. That's the way the book teaches it. I'm going to teach you the right way. What if negative f of negative x? And remember, this thing has got to equal my original equation. Are you following me? Okay. Do you see this part right here? What does that say? What does this say right here? F of negative x. Have I already figured out what that is? Are you following? So what does this say I have to do? Just change it. Basically, just change the sign. But I'm going to show it like this. Basically, it says all I do is take negative of what I just found, which is negative 2x to the third plus 3x. Are you with me on how I did that? I just used what I found and put it back in here, and I'm saying, okay, is that the same as my original? What happens when I distribute the negative? What does this negative do to this right here? So really, I get kicked out a 2x to the third. With me. What happens with this times this? What does that make it? And I look at this guy right here. Is it the same thing as what I started with? So what is this function going to be? It is an odd or an add function. It's an odd function, would be my answer. And there's my proof of why it is an odd function. So which do I need to check? What would be smart for me to check first every time? I need to check my even first, because if I'm going to check for odd, I use my even to check for my odd. Does that make sense? I use what I just found and I put it right there. And I just put a negative sign out here and I just distribute that negative sign. You following me? Okay, so alright, so to check if this is even, I do f at negative x. And I want to make sure that that kicks back the same thing. So I go 6 at negative x squared plus 10. Well, since this is to the second power, right, what's that actually going to kick back when I do that? Positive. So it's just going to be like if I had 6x squared. It's not going to change anything. Plus 10. Well, what happens when I look right here and I look right there? It's the same thing. So what do I know about this function? It's an even function. All right, so when I try this one, I go, okay, let's try f at negative x, which means I get a negative x to the third minus 3 negative x to the second minus 2 to negative x plus 7. And if I do that, what happens when I do this guy? Since it's to the odd, it's going to be negative x to the third. So if this is to the even power, what's it actually going to kick back? But positive times a negative 3 would still remain a negative 3x squared. Does everybody see what I just talked about? And then a negative times a negative would actually make this a positive 2x plus 7 would not change. You with me? Now I look at this guy. Did it kick back the same thing back here? So even, it is not. Yes? Now what do I do is I need to do negative f of negative x. Well, here's all I have to do. If you remember, why did we check even first? Because I'm going to use my even function right there, and all I'm going to do is change every sign. You can do this a faster way. You don't have to. Here's the fast way. I'll do the fast way after. I'm going to do it the long way in the beginning. I can do negative, and then I put parentheses. And I'm going to put everything I just found out, which is right here. Does everybody understand that? Negative x to the third minus 3x squared plus 2x plus 7. What does this negative sign really do to every one of these things in here? So all it becomes is x to the third plus 3x squared minus 2x plus, minus 7. Hold on. Is this the same thing as what I started with? Then it's neither. It is not odd. It would be even. Make sense? Questions on this? All right, so your homework. So for homework, you are going to be doing page 324 through 326 or 327. Numbers 1 through 17 odd, and that is in the skills practice. I'm going to put that up on in Portal. It's that PDF file. That will be your homework for tonight. That will practice some of these skills, especially the stuff that we just went over.